Today, we'll explore the science behind these powerful natural events, uncovering how and why they occur, and what we can do to stay safe. Earthquakes are sudden, violent shaking of the ground caused by movements within the Earth's crust or volcanic activity. But what triggers these movements? To understand that, we need to take a closer look at the Earth's structure. The Earth is made up of several layers: the crust, the mantle, and the core. The crust is the outermost layer, and it's broken into large pieces called tectonic plates. These plates float on the semi-fluid mantle beneath them and are constantly moving, though usually very slowly. The boundaries where these tectonic plates meet are called fault lines. Earthquakes typically occur along these fault lines as the plates grind against each other, collide, or pull apart. The energy stored up from these movements is released as seismic waves, which cause the ground to shake. There are three main types of plate boundaries: divergent, convergent, and transform. Divergent boundaries occur where plates move apart, convergent boundaries where plates move together, and transform boundaries where plates slide past each other horizontally. Each type of boundary can produce earthquakes, but in different ways. Let's start with divergent boundaries. When plates move apart, magma from the mantle can rise to fill the gap, creating new crust. This movement can cause frequent, but generally smaller, earthquakes. One famous example is the Mid-Atlantic Ridge. Next, we have convergent boundaries. Here, one plate is forced below another in a process called subduction. This can create powerful earthquakes, as seen around the Pacific Ring of Fire, where many of the world's strongest quakes occur. Finally, transform boundaries are where plates slide past each other horizontally. The friction between the plates can cause stress to build up until it's released in a sudden jolt, leading to earthquakes. The San Andreas Fault in California is a prime example. The point inside the Earth where an earthquake begins is called the focus or hypocenter. The point directly above it on the surface is the epicenter. The energy radiates outward from the focus in all directions, causing the ground to shake. Seismic waves are classified into two main types: body waves and surface waves. Body waves travel through the Earth's interior and include primary, P, waves and secondary, S, waves. P waves are the fastest and can travel through solids, liquids, and gases, while S waves are slower and only move through solids. Surface waves travel along the Earth's surface and usually cause the most damage during an earthquake. These include love waves, which move the ground side to side, and Rayleigh waves, which roll along the ground like waves in the ocean. To measure earthquakes, scientists use instruments called seismometers. These devices detect and record the vibrations caused by seismic waves. The data is then used to determine the earthquake's magnitude and epicenter. The magnitude of an earthquake is measured on the Richter scale, which quantifies the amount of energy released. Each whole number increase on the scale represents a tenfold increase in amplitude and approximately 31.6 times more energy release. While the Richter scale is commonly used, the moment magnitude scale, MW, is now more widely accepted by scientists. It provides a more accurate representation of an earthquake's size, especially for large quakes. Another important measure is the earthquake's intensity, which describes the effects on people, buildings, and the Earth's surface. The modified Mercalli intensity, MMI, scale is used for this purpose, ranging from I, not felt, to 12, total destruction. Earthquakes can cause significant damage, including building collapses, fires, landslides, and tsunamis. Tsunamis are large ocean waves generated by undersea earthquakes, and they can travel across entire ocean basins, causing devastation far from the epicenter. Scientists are continually improving methods to predict and mitigate earthquake impacts. Early warning systems, which detect the initial seismic waves and send alerts before the more damaging waves arrive, can provide crucial seconds to minutes for people to take cover. Engineering advancements also play a key role in earthquake preparedness. Buildings and infrastructure designed to withstand seismic forces can significantly reduce damage and save lives during an earthquake. Despite these advancements, earthquakes remain unpredictable. This is why it's essential for communities in seismic zones to have emergency plans, conduct regular drills, and ensure that buildings are up to code. Personal preparedness is just as important. Knowing what to do during an earthquake can make a life-saving difference. Remember the drop, cover, and hold on protocol. Drop to your hands and knees, cover your head and neck, and hold on until the shaking stops. In the aftermath of an earthquake, it's crucial to check for injuries and damages. Listen to emergency services, and be prepared for aftershocks. These smaller quakes can occur for days, weeks, or even months after the initial event. Education and awareness are vital in reducing earthquake risks. Many organizations offer resources and training to help individuals and communities prepare for earthquakes. Knowing what to expect and how to respond can significantly improve safety and resilience. Let's recap what we've learned today. Earthquakes are caused by movements in the Earth's crust, mainly along fault lines. These movements release energy as seismic waves, which we feel as ground shaking. Different types of waves and boundaries affect the intensity and impact of earthquakes. We also discussed how earthquakes are measured, the importance of early warning systems, and the role of engineering in reducing damage. Finally, personal and community preparedness can make a crucial difference in staying safe during and after an earthquake. We hope this video has given you a better understanding of the science behind earthquakes and how to stay safe. If you found this information helpful, please like, share, and subscribe to our channel for more science insights.